Welcome to this VCAA Specialist Maths exam paper series. The 2021 VCAA Specialist Maths exam paper 1 comprises of 9 questions. Students were not permitted to bring technology or notes into the examination. The exam paper 2 comprises of 20 multiple choice questions and 6 extended response questions. Students may use approved CAS technology in exam paper 2. In exam paper 1, students need to read questions carefully and demonstrate their understanding by clearly showing all appropriate steps leading to the given result in show that kind of questions. In exam paper 2, particularly in section B, students did not always correctly read and respond to the questions, where there was more than one aspect to the question. The areas of weakness include first, reading and responding to all aspects of questions. Second, using the correct angle to determine the gradient of a line. Third, explicitly justifying an answer when required. And fourth, carefully noting changing conditions in a mechanics problem.
Hello, Math Champions! I'm Dr. Chen. If you want to improve your math skills and understanding, so that you gain confidence, enjoy math more, and get better results, click subscribe and hit the notification button so that you don't miss anything.
Welcome to the first part of VCAA Specialist Maths 2021 exam paper. In this video, we will present exam paper 1 questions 1 to 4. It is worth mentioning that students generally did well in part A of question 1. In part B, some students have made basic algebra mistakes in presenting the final results. Meanwhile, some arithmetic errors were also observed in part C. In question 2, some students introduced errors in their working when using an unnecessary substitution. Most students were able to write down the null and alternative hypothesis correctly in part A of question 3. About 50% of the students did section 1 of part B well. Due to the confusion of the p-value with 0.01 as its significance level, about half of the students did not score in section 2 of part B in question 3. As for part C, some arithmetic errors were observed. In part A of question 4, students did not score well because they were not familiar with the trigonometry double angle formula. In part B, most students failed to recognize that dilating the graph from part A by a factor of 1 over k yields the graph and solid for part B. Welcome to this VCAA Specialist Maths 2021 exam papers. The first exam paper consists of 9 short answer questions, while the second exam paper consists of 20 multiple choice questions, plus 6 extended response questions. As for exam 1, we separate 9 short answer questions into 3 videos to explain them in details and hope you will find some help from them. In this video, we will present questions from 1 to 4 of exam 1 2021 paper. As it can be seen, question 1 says the net force acting on a body of mass 10 kg is 10I plus 12J newtons. There are 3 parts in question 1. Part A is to find the acceleration of the body under such a net force in meter per second squared. Part B is to find the velocity of the body at any time t seconds in meter per second, given that the initial velocity of the body is negative 3j meter per second. Part C is to find the momentum of the body in kilogram meter per second when t equals 2 seconds. Now, let's start to deal with part A. Since the net force F equals 5I plus 12j, according to Newton's second law, we have acceleration equals F over m, which equals 5I plus 12j, or in parentheses, over 10, which equals 1 over 2I plus 6 over 5j meter per second squared. In part B, Since the velocity of the body equals the integral of the acceleration with respect to time, the velocity v equals the integral of 1 over 2I plus 6 over 5j, or in parentheses with respect to t, which equals t over 2 plus c1, or in parentheses I, plus 6t over 5 plus c2, or in parentheses j. Since we know the value of initial velocity of the body, which is negative 3j meter per second, hence v of 0 equals c1i plus c2j, which equals negative 3j. So c1 equals 0, c2 equals negative 3. Now, v of t equals t over 2I plus 6t over 5 minus 3, or in parentheses j, according to the definition of the momentum. In part C, the momentum of the body equals its mass times its velocity. So p of t equals m multiplies v of t, which equals 5ti plus 12t minus 30, or in parentheses j. When t equals 2 seconds, p of t equals 10I minus 6j. Question 2 is to evaluate a definite integral from 0 to 1 of 2x plus 1, or over the result of x squared plus 1 with respect to x. The first step here is to simplify the integrand. Since 2x plus 1, or over the result of x squared plus 1, can be separate to 2x over the result of x squared plus 1, plus 1 over the result of x squared plus 1, using partial fraction technique. Then the integration can be written to the integral from 0 to 1 of 2x over the result of x squared plus 1, plus 1 over the result of x squared plus 1, or in parentheses with respect to x, which can be written to the integral from 0 to 1 of 1 over the result of x squared plus 1 with respect to the result of x squared plus 1, plus the integral from 0 to 1 over the result of x squared plus 1 with respect to x, which equals natural logarithm of x squared plus 1, or in parentheses plus arctangent of x, or valued from 0 to 1, which equals ln of 2 plus arctangent of 1 minus ln of 1 minus arctangent of 0, which is finally simplified to ln of 2 plus pi over 4. In question 3, it states that a company produces a particular type of light globe called shiny. The company claims that the lifetime of these globes is normally distributed with a mean of 200 weeks, and it is known that the standard deviation of the lifetime of shiny globes is 10 weeks. Customers have complained saying shiny globes were lasting less than the claimed 200 weeks. It was decided to investigate the complaints. A random sample of 36 shiny globes was tested, and it was found that the mean lifetime of the sample was 195 weeks. Use the values PR of z, which is greater than negative 1.96 but less than 1.96, equals 0.95, and PR of z, which is greater than negative 3 but less than 3, equals 0.9973 to answer 3 parts of this question. Part A is to write down the null and alternative hypothesis for the one-tailed test that was conducted to investigate the complaints. There are 2 sections in Part B. The first section is to determine the p-value of the test. The second section is about what the company should be told if the test was carried out at 1% level of significance. In Part C, the company decided to produce a new type of light globe called Globe Plus. The question is to find an approximate 95% confidence interval for the mean lifetime of the new globes if a random sample of 25 globe plus globes is tested and the sample mean is found to be 250 weeks. Here we assume that the standard deviation of population is still 10 weeks. Now let's start this question starting from part A. Since the question is to write down the null and alternative hypothesis for one-tailed test, the null hypothesis H0 says that the sample is drawn from a population which has the same mean lifetime, 200 weeks. However, the alternative hypothesis H1 says that the sample has been drawn from a population with mean lifetime which is less than 200 weeks. As for the first section of part B, since the sample standard deviation equals the standard deviation of population over the square root of sample size, which equals 10 over square root of 36, which equals 5 over 3 after being simplified. Hence, the p-value equals the probability of sample proportion, which is less than 195 under the condition that the population mean is 200 weeks, which equals PR of Z, which is less than 195 minus 200, or over 5 over 3, which is simplified to PR of Z, which is less than negative 3, which equals 0.00125. Here we continue to work on part B. For the second section of part B, since the calculated p-value, which is 0.00125, which can be written to 0.125%, according to the conventional p-value table, as it can be seen on the screen, that when p-value is less than 1%, we can say that we have strong evidence against the null hypothesis. In part C, since the sample mean, sample size, and the standard deviation of the population are known, and they are 250, 25, and 10 respectively, the standard deviation of the sample can be calculated, and it equals 10 over square root of 25, which equals 2. Hence, the approximate 95% confidence interval for the mean lifetime of 25 globe plus is in the range of sample mean plus or minus 1.96 multiplies the sample standard deviation, which is from 246.08 to 253.92. Question 4 has two parts. In part A, it states that the shaded region in the diagram is bounded by the graph y equals sine x and the x-axis between the first two non-negative x-intercepts of the curve, that is, the closed interval from 0 to pi. The shaded region is rotated about the x-axis to form a solid of revolution. The question is to find the volume Bs of the formed solid. In part B, the function is changed to y equals sine of kx, where k is a parameter, which is a positive real constant. The region bounded by the graph of the function and the x-axis between the first two non-negative x-intercepts of the graph is rotated about the x-axis to form a solid of revolution. The question here is to find the volume of this solid in terms of Bs. Now, let's start to answer part A of this question. Since the curve of the function is rotated about the x-axis in the closed interval from 0 to pi, the volume Bs equals pi multiplies the integral from 0 to pi of y squared with respect to x, which equals pi multiplies the integral from 0 to pi of the square of sine x with respect to x. Since the square of sine x equals 1 minus cosine of 2x, all over 2, Vx equals pi multiplies the result of x over 2 minus sine of 2x over 4, all valued from 0 to pi, which is simplified to pi squared over 2. In part B, since the function has a dilation factor k, we need to find the first two non-negative x-intercepts. We equate sine of kx equal to 0, which gives x equals n pi over k. Hence, the first two non-negative x-intercepts are 0 and pi over k. So, the volume V equals pi multiplies the integral from 0 to pi over k of y squared with respect to x, which can be written to pi multiplies the integral from 0 to pi over k of 1 minus cosine of 2kx all over 2 with respect to x, which equals pi multiplies the result of x over 2 minus sine of 2kx over 4, all valued from 0 to pi over k, which can be simplified to pi squared over 2k, which equals Vs over k.
If you enjoyed this video, please give it a thumbs up and subscribe to help me make more math content like this. I will see you in the next video.